Hello everyone, myself Hans. Today we are going to solve the problem of UPC 2009 from topic differential equation. Here in the question, show that the differential equation of all cones which have their vertex at the origin is px plus qy is equal to z. Then further verify that this equation is satisfied by the surface yz plus of zx plus of xy is equal to 0. Let's solve the problem. In the given question, set differential equation of all cones which have their vertex at origin. So we have to write here the differential equation of all cones having vertex at origin. This is given by ax square plus of by square plus of cz square plus of 2hxy plus of 2fyz and plus of 2zx. This is the equation of cones having vertex at origin, and the given equation differentiating partially equation 1 with respect to x and y, we get, first we have to differentiate partially with respect to x, taking y as a constant and z is the function of x. So we have to differentiating equation 1 with respect to x. This gives 2ax plus of, here we have to taking y as a constant, then by square is 0, and from here we have to, z is the function of x, so we have to write here 2cz and del z upon del x, further plus of, here 2hy is taking constant and differentiating x with respect to x, this gives 2h plus of 2f, and here is a z is the function of x, so we have to write here del z upon del x and plus of, here z and x is both are present and z is the function of x, so we have to take 2z as a taken constant, and using first second rule here, taking z is the first function and differentiating x with respect to x, this gives 1 plus of x and del z upon del x is equal to 0, and we know that del z upon del x is p, so we have to put here in place of del z upon del x we put p, this gives 2ax plus of 2cz, in place of del z upon del x we have to put here p plus of 2h and 2h, where once again when we have to differentiating 2hxy with respect to x, this gives 2hy here, 2hy, and this gives 2hy plus of 2f, in place of del z upon del x we have to put p plus of 2z, and here is z plus of xp is equal to 0, and taking 2 common from left hand side, this gives 2 is taking common, this is ax plus of czp plus of hy plus of fp. Once again when we have to differentiating here, fy, 2fy, here z is a function of x, so we have to write here once again, here is y is also present, this is fyp, and so we have to write here fyp plus of g, we have to multiply here, this gives gz plus of x gp is equal to 0, and from here 2 is taken to equal to 0, and the remaining is ax plus of, we have to take czp and fyp and xgp in one bracket, and taking p common, this gives cz, and here is plus of f of y, and here is plus of, we can also write gx, and the remaining is here, this is hy plus of gz h plus of hy in plus of gz is equal to 0. Let this equation 2. And equation 1, again differentiating with respect to y, taking x as a constant and z is the function of y. So we have to write here ax square is 0, and differentiating by square with respect to y, this gives 2by plus of cz square, differentiating with respect to y, this gives 2cz del z upon del y, and here plus of 2hxy, differentiating with respect to y, this gives 2hx and 2fyz, here y and z is the function of y, so we have to use here first second rule, taking 2f as a taking 2f is constant, taking outside, and we have to use formula of first second differentiating yz, taking y is the first function and differentiating z with respect to y, this gives del z upon del y, and plus of z, and differentiating again y with respect to y, this gives 1, and plus of here 2gzx, here 2gx is taking constant and z is the function of y, so we have to differentiating with respect to y, this gives del z upon del y, and we know that del z upon del y is written as q, so we have to put in place of del z upon del y, we have to put 0, this gives del z upon del y, in place of we have to put q, not 0, this gives 2by plus of 2cz, in place of del z upon del y we have to put q, and plus of 2hx and plus of 2f bracket, here in place of del z upon del y we have to put q and plus of z, and plus of 2gx, in place of del z upon del y we can also put here q is equal to 0, and further we can take two common from left hand side, this gives 2 is taking common, this is by plus of czq and plus of hx, and plus of we have to multiplying, taking 2 common and multiplying f with this bracket, this gives fyq and plus of fz and plus of gxq is equal to 0, and 2 is taken equal to 0, then the remaining is here, this gives by plus of czq plus of hx plus of fyq and plus of fz plus of gxq is equal to 0, And further we have to write also once again. Further we have to write, this is written as by plus here czq and fyq and gxq is taken one bracket, taking q common, this gives here cz plus of fy and here is plus of gx, and the remaining is here hx plus of fz is equal to 0. This is the equation third. And equation 2 multiplying with x, and equation third multiplying with y first. Then we can also once again we have to write here adding equation 2 multiplying with x plus of equation 3 multiplying with y, and we have to write here, we have to multiply equation 2 with x, this gives multiplying with x, here we can also mention here multiplying with x both the sides, this gives ax square and plus of we can once again plus of px, and this is cz plus of fy plus of gx and plus of hxy and plus of gzx, and we have to adding equation 2 multiplying with x, first we have to multiply with x and adding equation third multiplying with y, here we can also mention multiplying with y, we have to multiplying with y, this gives plus of by square and plus of qy in the bracket here cz plus of fy plus of gx and plus of hxy, when we have to multiply hx with y, and plus of fz multiply with y, this gives fyz is equal to 0, and further we have to solve once again. Further we have to solve, we can also write this is ax square and by square is taking first this is by square, this is taken and this is taken, and further we can also hxy and here is also hxy, we have to write plus of 2hxy and here is zx and here is also once again hxy, this gives, we have to write here plus of zx and plus of fyz once again fyz, we have to take it fyz gz, and further from here this gives cz plus of fy plus of gx, we have to take common from here, once again we have to taking common px into cz plus of fy plus gx and qy bracket cz plus of fy plus gx, taking common, this is cz plus of f of y plus of gx is taking common, and in the bracket is here px and here is plus of qy is equal to 0, and from equation 1 we can also put using equation 1 once again. Using equation 1, we can also write equation 1 in the form of this is ax square plus of by square, and once by square we have to take x square plus by square and plus of 2hxy 2hxy, and we can break fyz in the terms two times. We have to write this is plus of fyz and plus of fyz, and further 2gzx is written as gzx plus of gzxx, and here is plus of cz square is equal to 0. We can also write in the form of equation 1, and from here we have to take once again ax square plus of by square plus of 2hxy and plus of gzx and plus of fyz, and the remaining is taken to right hand side. First we have to taking right hand side is cz square minus of cz square, and one gzx is taken to left hand side and one is taken to right hand side. This gives minus of gzx, and further one fyz is taken to left hand side and one fyz is taken to right hand side. This gives fyz, and the remaining is once again we have to check x square by square 2hxy, and here is gzx cz square, and further we can also put here, we can also take a minus common. We can also write this is cz square plus of gzx plus of fyz, and we have to put here in place of ax square plus by square plus 2hxy plus of gzx plus of fyz. In place of we have to put minus of cz square and plus of gzx and plus of fyz, and further is here this is plus of cz plus of fy plus of gx into px plus of qy is equal to 0, and we have to take common cz. We have to take in common, that is cz plus of fy plus of gx is taking common, and the remaining is here. When we have to take common cz plus fy plus gx is taking common, here remaining is once again here is fyz. Once again when we have to take common cz plus of fy plus gx is taking common. Once again taking common, here remaining is z. Once again cz plus, once again we have to here we can also take common from here, that is z. This gives cz plus of gx plus of fy and plus of cz plus of fy plus of gx into px plus of qy is equal to 0, and here is cz plus of gx plus of fy is taking common, then remaining is cz plus of gx plus of fy is taking common, and the remaining is here minus of z, and here is plus of px plus of qy is equal to 0. And we have to take once again we have to take in cz plus of gx plus of fy is equal to 0, and then in the second bracket this gives minus of z plus of px and plus of qy is equal to 0, and we have to find the relation, that is px plus qy is equal to z. So we have to put the second bracket is equal to 0. This gives px plus of qy, and minus of z is taken to right hand side. This gives equal to z. We have to find the first relation. The equation of differential equation having vertex at origin is px plus qy is equal to z. This is the first part of the solution, and further in the given question said verify that this equation is satisfied by the surface. So we have to further solve by for second part. We have to solving second part. This gives given surface is yz plus zx plus of xy is equal to 0, and from here we have to differentiating, let this equation 1 and differentiating equation 1 with respect to x and y, and here when we have to differentiating with respect to x, taking y as a constant and z is the function of y, and then when we have to differentiating with respect to y, taking x as a constant and z is the function of y. First we have to differentiating with respect to x. This gives here taking y as a constant and z is the function of x, so we have to write here del z upon del x, and plus of here z and x differentiating with respect to x. Here z is the function of x, so we have to use first second formula. This gives z is taking first function and differentiating the second function, x is 1 plus of x and del z upon del x, and plus of here xy. Here xy, here y is taking as a constant and x differentiating with respect to x. This gives only y is equal to 0, and from here we know that del z upon del x is p, so we have to write here this is yp plus of z plus of xp plus of y is equal to 0, and we can also write in the form of this is once again we can also write this is z plus of y and minus of yp and minus of xp, taking plus of yp and plus of xp into right hand side, and further we have to take minus of p is common. This gives minus of p is common. This gives x minus of y, sorry x plus of y. When we have to multiply, this gives minus of px and minus of py, and further again we have to differentiating equation 1 with respect to y, taking x as a constant. This gives here y and z. Here differentiating with respect to y, here z is the function of y, so we have to use the first second formula. This gives z is taken as the first function and differentiating y with respect to y. This gives 1, and again we have to put once again here is y, and again del z upon z is differentiating with respect to x. This gives del z upon del y, and here zx, here x is taken as constant and z is the function of y, so we have to write here x del z upon del y, and plus here x is taken as constant and differentiating with respect to y. This gives plus of x is equal to 0, and we know that del z upon del y is q. So we have to put here z plus of yq plus of xq plus of x is equal to 0, and we can also write here this is z plus of x is equal to minus of yq and minus of xq. Plus of yq and plus of xq is taken into right hand side, and taking minus q common, this gives x plus of y. And further we can also write in the form of this is z plus of x upon minus of q is equal to x plus of y. Let this equation third, and from here we can also write this is z plus of y upon minus of p is equal to x plus of y. Let this equation second, and from equation once again from equation 2 and third, here the right hand side of the equation 2 and right hand side of the equation third are same, so we have to put equal, so we have to put the left hand side are also equal, so we have to write here z plus of y upon minus of p is equal to, here is z plus of x is equal to minus of q, and further we have to cross multiplication, this gives minus of qz and minus of qy is equal to minus of pz and minus of px, and we have to take minus of qz minus of qy and minus of pz and minus of px is taken into left hand side, this is plus of pz and plus of px is equal to 0, and further we have to proceed, further we have to show verify this equation is satisfied by the surface. So we have to write here once again, we can also px plus qy, we can also multiplying, once again we have to write here satisfied by the given surface. If px plus qy is, we have to earlier find px plus qy is equal to z, we have to prove earlier, and we use the following result here. This gives px minus of qy is here, so we have to write here once again we can also write once again surface